Hey, hi YouTube. I hope you all guys are doing great. In this video, we are going to discover cache replacement policies. So in previous two videos, I have launched about the cache and cache architecture. So if you don't know about cache and the cache architecture, so you, go and watch that video if you are a bit interested in knowing the architecture of caches. And it is very important because a term which is cache line will be coming repeatedly in this video. So it's very important. Okay. So first of all, let's see what actually cache replacement policies are. So cache replacement policies are mechanism used in CS computer system to determine which cache line should be evicted or replaced when a new block of data needs to be brought into the cache. So if you don't know about cache line or cache block, so basically whenever CPU needs some data, it's try to watch into the cache like L1 first into L1 cache, then to L2, then L3. If it is not present in cache, it try to see in the RAM, okay, the primary memory, then into the secondary memory. So the method or the transport or the data block through which the data, if it is not present in cache, if you are trying to bring it into the cache from the secondary memory or from the primary memory, it is done through the cache lines. Okay, so cache are small, fast memory units that store frequently accessed or recently used data. The aim is to reduce the latency of accessing data from a slower main memory because we know main memory is slower. Since cache space is limited, a cache replacement policies help to decide which data should be retained in the cache and which should be replaced to make room for the new data. The need of cache replacement policies arise from the finite size of cache and the desire to maximize the hit rate. In the previous video, I have also talked about what is cache hit and cache miss. Okay, so if you are trying to find some data which is needed in CPU and if it is present in cache, we call it as cache hit. If it is not present, it is cache miss. In case of cache miss, then you have to bring the data from RAM or from the another memory to the cache through the cache lines. So the need of cache replacement policies arise from the finite size to maximize the hit rate. Okay, when a processor requests data, the cache is first checked. If the required data is found in the cache, we call it as cache hit. It saves time compared to fetching the data from the slower main memory. However, if the data is not in cache, which we call as cache miss, the system needs to decide which cache lines is to evict to make space for the new data. So that's why we need cache replacement policies. Okay, so there are different cache replacement policies. First one is random replacement policies, then first in, first out, list replacement unit, list frequently used kind of replacement policies. So we will see one by one. First one is random replacement policy. By the name, it is clear random replacement policy. So definitely we are trying to remove some random cache lines, okay, without thinking anything. This is like a no-brainer, but it is also helpful sometimes. So the random cache replacement policy is one of the simplest cache replacement policies. In this policy, when a new item needs to be loaded into a cache and there is no space, a randomly chosen cache line is replaced. Okay, this sounds very uh, without any efficiency. This means then that any existing cache line has an equal probability of getting selected. Let's suppose we are having this cache lines A, B, C, D. Let's suppose initially, let's suppose we are having 5 cache lines, okay? And this is the limit, okay? Let's suppose in our cache only 5 cache lines can be taken place. So now if we are trying to introduce a F cache line, anyone can be replaced. Either B can be replaced and it will become A, F, C, D, E. Either C can be also replaced and it will become A, F, D, A, B, F, D. So it's a random choice. Okay, so the random replacement policy doesn't follow any specific pattern or it doesn't prioritize any particular cache line for replacement. It simply selects a cache line randomly when a replacement is necessary. While this is simple, the policy may not be always most effective. Obviously, it can't be most effective, okay, in terms of maximizing the hit rate. Why we are doing cache replacement policies? One line answer is to maximize the cache hit. So obviously the cache hit will be not improved by random replacement policy, but however it is easy to implement and may be suitable for certain applications or scenarios where the overhead of tracking access history is not justified. Okay, it can be helpful in some scenarios. Okay, then coming to first in first out replacement policy, I think if you have heard FIFO, Q might be coming in your brain. Okay, if you have done a bit DSA. Okay, so first in first out replacement policy is based on principle of replacing oldest cash line. Okay, which one is old? Remove it. Okay, so it's follow a queue like structure where the first item that was loaded into the cache is needs to be replaced. Okay, let's suppose we are having let's suppose our cache lines have a limit of 4. Okay, only 4 line can be uh, take place. Okay, so first of all, let's suppose cache line A in let's suppose we loaded A data. Okay, then another cache line appeared B, then another cache line appeared C, then we loaded another cache line D. Now, as I already told you that our limit is of 4. Now, if I have to bring another cache line, let's suppose F, then which should I remove? I will remove the oldest one. Which is the oldest one? A, because A was the oldest one. So now it will become F, B, C, D. It's like a queue. Okay, first in. Which was first in? A. Which will be first out? A. So that's why if we want new cache line, F, the oldest one will be replaced. While FIFO is simple to implement and has low overhead, it may not always provide optimal performance, especially scenarios where access patterns are not strictly based. Because here the pattern is clear that okay, we have to remove the oldest one. Then we can use FIFO replacement policy in caches. But if the scenarios are not clear, then it can't be a optimal solution. More advanced cache policies like LRU, LFU may be more effective in certain situations. Now let's see what is LRU. LRU is basically least recently used replacement policy. So let me write it. Least recently used. Okay, by the name it is clear, I guess. I think if you understand the name, it's very easy, the replacement policy. The LRU policy aims to evict the cache or replace the cache line that has not been accessed for a longest time. Okay, in other words, it prioritizes keeping in the cache the items that have been accessed most recently. Implementing LRU requires maintaining some form of access history for each cache line. Okay, now let's think that we are having a limit of 3 cache line. Okay, cache object 1, cache object 2, and cache object 3. We have only limit of 3 cache line that we can store only 3 cache objects or 3 cache lines. Let's suppose initially our cache is empty, and let's suppose we loaded A into our cache. Our cache will look like this. Now we have loaded another line which is B. Now we have loaded another item on the cache. Let's suppose it is C. Okay. Now if we want to load item B into the cache, so which will be replaced? Which will be replaced? Because A will be replaced because it is least recently used. See, first of all we used A, then we come to B, and then we come to C. So which is at this point of time, which is least recently used? It is A. So now if we load the D, then it will become DBC, not DBC actually. It will become BCD. Okay, BCD, because now B will move to the first priority and it will become BCD because A was least recently used, so A will be evicted. Okay, now let's say there is a cache miss and item A which we have replaced need to be loaded again. Okay, so which will be replaced? Now B is least recently used, so it will become CDA. Okay, not ADC. Okay, it will not become A, sorry, ACD. C will now become the least recently used, and this will be the most recently used because we have accessed it just recently. So it will become CDA. Okay, implementing LRU efficiently can be a bit challenging as it requires maintaining, updating access history information for each cache line. There is a famous question also at LRU you can try if you are from computer science background and solving some DSA questions. Various methods such as counter, stacks, or linked list can be used to achieve this. While LRU can provide good performance in capturing recent access patterns, it may have higher implementation overhead compared to simpler policies like FIFO or random replacement. But if you ask me, this looks much more logical. Like which is not recently used, just remove it. Okay, but it is not like it will be good for every scenarios. Okay, now let's see another one which is LFU, which we call as least frequently used. Okay, least frequently used. So least frequently used replacement policies aims to evict the cash line that has been accessed the least number of times. Okay. LFU keeps the track of access frequency of each cache line and selects the one with the lowest frequency of replacement. Let's suppose again we have a limit of cache objects 3, like we can at a time we can have only 3 cache lines. Okay, so now let's suppose we load first of all we loaded A. Okay, so it will become in our cache it will become A and the frequency of A is 1. Okay, now we loaded another item which is B. So we are having cache frequency as A as 1, B as 1. Okay. Now, let's suppose we again try to access A. So, in case of cache hit. So, if in our cache, if already there are A and B, and if I again try to access A, it will be a cache hit. And obviously, it will be not loaded, but the frequency of A, because we have accessed it 2 times, so it will become to 2. Okay. Now let's suppose I loaded C. So it become A, B, C and the frequency becomes A2, B1 and C1 because C has been accessed 1 time. Now let's suppose again we try to access C. So there is a chance of obviously there will be a cache hit, but the new item will be not loaded, but the frequency will increase. A will become 2, B will become 1 and C will become 2. Okay, now let's suppose we are trying to load D. So one of them which is having the lowest frequency will be replaced. Which is having lowest frequency? It is B. So if we try to load D, it will become something like A, C, and D. Okay, so now the frequency of A will become 2, D will become 1, and C will become 2. Okay, so now here you are getting like if frequently used, the least frequently used cache line will be replaced. Like in this case, it was B. So implementing LFU requires maintaining or updating access frequency information for each cache line, like we were doing here. This can be done using counters associated with each line. While LFU can be effective in certain scenarios, it may struggle in situations where access patterns change dynamically. Okay, and items that were frequently used in the past become less relevant. So it depends. Obviously all things depend. Yeah, it is not like every time you have to use LFU or LRU. Sometimes even the random replacement policies can be beneficial. It depends. So the choice of cache replacement policy depends on factors such as specific application, system architecture, hardware constraints. Okay, the goal is to strike a balance between simplicity of implementation and maximizing the cache hit rate. If you are trying to implement a cache replacement policy, so the most important part is to maximizing the cache hit rate, thereby improving all system performance. Obviously, if you improve cache hit rate, then the whole system performance will be improved. So that's it for this video. In next video, we are gonna see cache write policies. So if you like this video, please like this video and you can share with someone who really needs to study it or who is trying to study it. And if you have any doubt, you can write in the comment section. I feel very happy to answer all your doubts and whatever suggestions you have. So that's it. Meet you in the next video. Till then, bye bye.